Hello everyone, welcome back to Maths Marathon classes. In this session, I'll be doing 2025 JEE main application of derivatives, second PU topic. I'll be covering both January and April shift, okay? So, totally there are 10 questions asked from this, including both January and April shift, because some topics are deleted at present from the JEE syllabus as well. We had earlier tangent and normal, correct? Increasing and decreasing functions is there, but tangent normal is deleted. Okay, so number of questions is quite less compared to other topics from this chapter. One question is asked from rate measure, increasing and decreasing function, one question, local maxima and local minima, 5 questions were asked, absolute maximum and absolute minimum, one question, and miscellaneous, 2 questions. That is questions which contains multiple concepts. Okay, so mixing type of questions are there, that is 2 questions. Are totally there are 10 questions. We'll discuss one by one. Okay, we'll take the first question. The function f of x is given like this. A cubic polynomial is given where a is positive, attains its local maximum and local minimum values at p and q respectively, such that p square is equal to q. Find f of 3. Okay, question asked on 2nd of April, 1st of 2025. So our aim is to find the value of a using this condition. Local maximum at p, local minimum at q. Okay, and the given p square is equal to q. So using this condition, p square is equal to q, you need to find the value of a. Then once you get the value of a, substitute back, a very simple question, then you can find f of 3. Not a difficult question at all. Okay, first we'll apply the conditions for local maxima and local minima. Local maxima, local minima conditions are what? The first derivative should be equal to 0, common condition for both maxima and minima, local maxima and local minima. If second derivative is positive, it's local minima. If second derivative is negative, local maxima. We know the conditions for local maxima and local minima. Using that, I'm finding out this. Okay, we'll find f dash of x first here. F dash of x. Differentiate the cubic polynomial. Derivative of 2x cube is 6x square minus 9a into derivative of x square 2x, that is minus 18ax. Derivative of 12a square x is 12a square. You can take 6 common here, correct? 6 is common from this. Terms inside the bracket will be x square minus 3ax plus 2a square is equal to 0. Correct? I'll use f dash of x equal to 0 to get the critical points. 6 cannot be equal to 0, so terms inside the bracket will be equal to 0. Correct? This implies x square minus 3ax plus 2a square is equal to 0. As you know, 6 can't be equal to 0. Product of two numbers equal to 0 means either a equal to 0 or b equal to 0. We should factorize this. Adding, we should get minus 3a. Multiplying, we should get 2a square. Factorizing this as x minus a into x minus 2a equal to 0. Correct? Product of two numbers equal to 0 means either the first number is equal to 0 or the second number is equal to 0. A into b 0 means either a equal to 0 or b equal to 0. So critical points, I'll get x equal to a, x equal to 2a. So when x equal to a, you find out the second derivative, as well as when x equal to a also, you find out the second derivative. Given that a is a positive number, correct, you'll find out f double dash of x from this. F double dash of x is how much? F double dash of x. F double dash of x is equal, differentiate this. Derivative of 6x square is 12x. Derivative of 18ax is 18a. Correct? Derivative of 12a square is 0 because 12a square is a constant. Now find out the second derivative at x equal to a. F double dash of a is how much? F double dash of a is equal to, putting x equal to a in that, 12a minus 18a, which is equal to minus 6a. Minus 6a is going to be negative because a is positive already given. So minus 6a is negative because they mentioned in the question that a is positive. So at x equal to a, second derivative is negative. That means it has local maxima. At x equal to a, f as local maxima, I can conclude. at x equal to a, the function f has local maxima. What about at x equal to 2a? You have double dash of 2a at x equal to a. That's another critical point. Substitute x equal to a in this. 12 into 2a, that is 24a. 24a minus 18a, that comes to 6a. 6a is positive because a is positive, right? So second derivative is positive, means we can conclude that x equal to 2a is a point of local minima. At x equal to 2a, the function f has local minima. So according to the question, local maximum is at P and local minimum is at Q, correct? So this will be x equal to A is local maxima, that is P. Given P square is equal to Q, correct? Given condition is P square is equal to Q. I'll take P as A because according to the question, local maximum is at P, correct? So A is the point of local maxima. Substitute P as A. So A square is equal to Q. Q is 2A because according to the question, Q is the local minima. Q is the point of local minima. So here x equal to 2A is the point of local minima. In place of Q, you can put 2A. I can cancel here 1a because a is not equal to 0. I can cancel 1a. So I'll get a is equal to 2. A is not equal to 0. I'll cancel it. That told a is positive number. So a is equal to 2 I got. Substitute this value of a equal to 2 in the original equation. Given function f of x. Given function f of x becomes, put x equal to a and write 2x cube minus, putting x equal to a, that 9 into 2, 18. 18x square. 12 into 2 square, a is equal to 2, we got 2 square is 4, 4 into 12, correct? 2 square is 4, 4 into 12 is 48x, 48x plus 1. We got the polynomial f of x. Now we need to find f of 3. Therefore, f of 3 is equal to, put x equal to 3 and write, 3 cube is 27, 27 into 2, that is 54. Here 3 square is 9. Correct? Putting x equal to 3, 3 square is 9, 9 into 18, that is 162. 48 into 3, 48 into 3 is 144 plus 1. How much you get? 54 minus 162 minus 108. Minus 108, this is 145. How much you get? Minus 108 plus 145, that is 37. 37 is the answer. Option B. Hope I understand. Please make a note of this. Similar type of question were asked in the previous year also. If you refer to all the previous year questions of JEE exam, definitely at once this question was asked many years back, I remember. Okay. So 37 is the answer. Solution is also shown to you here. A detailed solution is given here. Okay. Move on to the next one. Question number 2. A function f from R to R is defined by this, f of x equal to mod x plus 2 minus 2 mod x. M is the number of points of local minima and n is the number of points of local maxima of f. Want to find m plus n. 3rd of April, 2nd shift, 2025. So we need to simplify the given function and find the points of local maxima and local minima. Okay. So given function f of x, we shall rewrite it because there is modulus function, no? Given function f of x equal to mod x plus 2 minus 2 mod x. It's given like this, correct? We shall redefine this, okay? First I'll remove this modulus function. Mod x I'll simplify. We know mod x is x if x is greater than or equal to 0. Mod x is minus x if x is less than 0. We'll simplify this modulus function first, mod x. Then I'll remove this mod x plus 2. Mod x plus 2 will be x plus 2 if x plus 2 is greater than or equal to 0. Or minus of x plus 2 if x plus 2 is less than 0. I'll apply the definition of modulus function and simplify it first. This I'll split into 2 cases first. Okay? Split in 2 cases. Mod x plus 2 mod x plus 2 minus 2 into this mod x, I'll write x. This is for x greater than or equal to 0. X greater than or equal to 0. Mod of mod x plus 2 minus 2 into mod x will become minus x if x is negative. So minus 2 into minus x will become plus 2x. This is if x is less than 0. Okay. Now I'll simplify this mod x plus 2 in the next step. This will simplify to two cases. Mod x plus 2 will be x plus 2 if x plus 2 greater than or equal to 0, or mod x plus 2 will be minus of x plus 2 if x plus 2 is less than 0. This is split into two cases, and this will also split into two cases. 4 cases will come now. Okay. So from this, rewriting this further, okay, this is equal to mod x plus 2 will be x plus 2 if x plus 2 is greater than or equal to 0. This will be mod of x plus 2 minus 2x. This is for x plus 2 greater than or equal to 0. That means x is greater than or equal to minus 2, and already we have x is greater than or equal to 0. Second case from there, mod x plus 2 is minus of x plus 2, correct? So minus of x plus 2 minus of x plus 2 minus 2x. This is for x plus 2 less than 0. That means x is less than minus 2, and already we have x is greater than or equal to 0. So this is being split into two cases. And coming to the second line, that will also split into two cases. Mod x plus 2 is x plus 2 if x plus 2 greater than or equal to 0. Mod x plus 2 is minus x plus 2 if x plus 2 is less than 0. Okay, so from this, what we get, mod of, this is x plus 2 plus 2x. X plus 2, mod x plus 2 is x plus 2 if x plus 2 is greater than or equal to 0. So mod of x plus 2 plus 2x. This is for x is greater than or equal to minus 2, and already we have x is less than 0. That is one possibility. And mod x plus 2 is minus of x plus 2, right? Minus of x plus 2 plus 2x we have already there. Correct? This is if x plus 2 less than 0. That means x is less than minus 2, and already we have x is less than 0. Like this. So now, and means intersection. Common values you should take for x greater than or equal to minus 2 and x greater than or equal to 0. So if you take a number line, I can take the intersection easily. X greater than or equal to 0 means 0 to infinity. X is greater than or equal to minus 2 means minus 2 to infinity. So common to these two is x greater than or equal to 0, right? If you can't understand, I'll represent this. For example, for instance, this is minus 2 here. This is 0 here, correct? X is greater than or equal to minus 2 means minus 2 to infinity. X is greater than or equal to 0 means 0 to infinity. Common to these two will be x greater than or equal to 0. So intersection of these two is x greater than or equal to 0. Okay, this will be the common value. I can mark it in some other ink. I'll represent this is common. I'll get. And coming to this, x less than minus 2, x greater than or equal to 0. Can we get an intersection point for this? X less than minus 2. Minus 2 is here and greater than or equal to 0. This is going right side of 0. This is left side of minus 2. There is no common point for x greater than or equal to 0 and x less than minus 2. So this case is not possible at all. This case is not possible, right? This case is not possible. So this is invalid. I'll reject that. Okay. Now x greater than or equal to minus 2 and x less than 0. Coming to this third case, I'll mark the points minus 2 and 0. According to this, x less than 0. That means left side of 0 excluding 0. And this is x greater than or equal to minus 2 means including minus 2, right side of minus 2. Common to these two will be minus 2 to 0. This case is possible. So it belongs to, the x belongs to the closed open interval minus 2 to 0. Okay. And the last case, x less than minus 2 and x less than 0. That is, again I'll mark minus 2 and 0. According to this, x less than minus 2 means left side of minus 2. X less than 0, left side of 0. Common to these two will be x less than minus 2. Correct? So this case is possible for x less than minus 2. And this case is possible for x belongs to the closed open interval minus 2 to 0. Okay. So I'll rub this. Okay. Hope you understand. The second line I'll reject it because that case is invalid. Only the first line, third line and fourth line will remain. So I'll get 3 cases. 2 cases made into 4 cases and 1 case is rejected because it is not valid. So there is no common point for x less than -2 and x greater than or equal to 0. So I'll consider the first, third and fourth line. So I'll get only 3 cases. Okay. Hope you understand this. This part is not required. We shall rub this. Now, f of x simplifies to, my f of x will be equal to, watch, here, simplify and write, 2x minus 2x is minus x, right? So, mod of 2 minus x I'll get there. X minus 2x will simplify to minus x. So, first case, this is for x greater than or equal to 0. What we have? Mod of 2 minus x. Mod of 2 minus x. This is for x greater than or equal to 0. Because intersection of these two is x greater than or equal to 0. Mod of 2 minus x. Second line is invalid, rejected, because that case is not possible. Here I am getting mod of 2 plus 3x, that is mod of 3x plus 2. Mod of 3x plus 2. That is for x belonging to the closed open interval, as I told. X belongs to the interval minus 2 to 0. Okay. And the last case, this is minus x minus 2. Minus x plus 2x will be plus x minus 2. Mod of x minus 2 it becomes. Mod of x minus 2. This is if x is less than minus 2. Common to these two is less than minus 2, correct? Hope you understand. Open the bracket here within the mod. Minus x plus 2x, that is plus x minus 2. So, now, again I can divide this, okay, f of x. For x greater than or equal to 0, given function is mod of 2 minus x. We know mod of 2 minus x same as mod of x minus 2, correct? Mod of minus 1 is same as mod 1. Mod of minus 3 same as mod 3, right? So, mod of 2 minus x is same as mod of x minus 2. I'll split it at x equal to 2. Because I want to have only for x greater than or equal to 0, I can rewrite the first line for, that is, the first line can be further split like this. Mod 2 minus x is same as mod x minus 2. And mod x minus 2 will be x minus 2. Correct? If x is greater than or equal to 0. If x is greater than or equal to 2, sorry. Mod x minus 2 will be x minus 2 if x is greater than or equal to 2. And mod x minus 2 will be minus of x minus 2 if x is less than 2. If x is less than 2 but it is greater than or equal to 0, right? So, x is greater than or equal to 0, 0 less than or equal to x, less than 2 I'll write. I'm splitting it x equal to 2. Okay. First line is divided into 2 cases. Coming to this, mod of 3x plus 2, where is the critical point for this? The critical point is where the terms inside the mod becomes equal to 0. 3x plus 2 becomes 0 for x equal to minus 2 by 3. Minus 2 by 3. Minus 2 by 3 lies in this, correct? So, I can discuss for x less than minus 2 by 3 and x greater than minus 2 by 3. 2 cases will arise there. So, mod of 3x plus 2 will be 3x plus 2 itself. 3x plus 2. If x is greater than or equal, 3x plus 2 is greater than or equal to 0. That means x is greater than or equal to minus 2 by 3. Minus 2 by 3 to 0. That is x is between minus 2 by 3 to 0. Including minus 2 by 3 excluding 0. And mod of 3x plus 2 is minus of 3x plus 2. Minus of 3x plus 2. This is for 3x plus 2 less than 0. Means x is less than minus 2 by 3. So that means x lies in the interval minus 2 to minus 2 by 3. Correct? And the last case, for x less than minus 2, it is mod x minus 2. Less than minus 2, if you take any number, x minus 2 is negative only. Say less than minus 2, you can take minus 3. Put x equal to minus 3. Minus 3 minus 2 is minus 5. So x minus 2 is negative only. Any number less than minus 2, if you take, x minus 2 is negative. So x minus 2 is negative means mod x minus 2 is minus of x minus 2. Correct? So minus of x minus 2. This is for x is less than minus 2. So totally we have 5 cases. Okay. So x greater than or equal to 2. X between 0 to 2, x between minus 2 by 3 to 0, minus 2 to minus 2 by 3, x less than minus 2. We can start from the down, correct? From the bottom to top we can go. So the critical points are the turning points, the doubtful points where the derivative sign changes will be minus 2 is there, correct? 0 is there, minus 2 by 3 is there, 2 is there. So now you can differentiate and find f dash of x. So far we are not differentiated at all. This is f of x still, correct? Now I'll find f dash of x. F dash of x is equal to what? F dash of x. Differentiate. Derivative of x minus 2 is 1. This is if x is greater than or equal to 2. Next, derivative of minus of x minus 2 is minus 1. This is if x lies between 0 and 2, including 0, excluding 2. Derivative of 3x plus 2 is 3. This is if minus 2 by 3 less than or equal to x less than 0. Next one, derivative of minus 3x plus 2, that is minus 3. Minus 3. This is for x between minus 2 and minus 2 by 3. Last case, derivative of minus of x minus 2 is minus 1. This is for x less than minus 2. So from the bottom to top I'll come. Okay. So for x less than minus 2, derivative is negative. For x greater than or equal to minus 2, so derivative is negative. I'm using the first derivative test to find the points of local maxima and local minima. What does first derivative test tells you? The function should be continuous, and if f dash of x changes the sign from positive to negative at the point when it passes through some point, okay, then the function is said to have local maxima. If f dash of x changes sign from positive to negative, if f dash of x changes sign from negative to positive, it is local minima. So at x equal to minus 2, less than minus 2, derivative is negative. Greater than minus 2 also, derivative is negative. Sign does not change in the neighborhood of x equal to minus 2. So the point of maxima minima does not occur there. Okay. So come to next point at minus 2 by 3. So x less than minus 2 by 3, derivative is negative, correct? And x greater than or equal to minus 2 by 3, derivative is positive. So at minus 2 by 3, at x equal to minus 2 by 3, derivative sign changes, correct? So less than minus 2 by 3, derivative is negative. Greater than minus 2 by 3, derivative is positive. So in the neighborhood of x equal to minus 2 by 3, I can conclude that derivative sign changes from negative to positive. So local maxima, local minima at x equal to minus 2 by 3 is a local minima. Derivative sign changes from negative to positive, local minima. So x equal to minus 2 by 3 is a point of local minima, I can write here. X equal to minus 2 by 3 is a point of local minima. X equal to minus 2 by 3 is local minima. Hope you understand. Local minima. Okay. Next, you take a derivative at and the neighborhood of x equal to 0. X less than 0, derivative is positive. X greater than or equal to 0, derivative is negative. So derivative sign changes from positive to negative in the at x equal to 0. In the neighborhood of x equal to 0, less than 0, derivative is positive. Greater than or equal to 0, derivative is negative. At x equal to 0, you have dash of x changes from positive to negative. So local maxima at x equal to 0. X equal to 0, there is local maxima. X equal to 0 is the point of local maxima. Okay. Next, at x equal to what happens? X less than 2, derivative is negative. X greater than or equal to, derivative is positive. So again, in the neighborhood of x equal to 2, derivative sign changes from negative to positive, means at x equal to 2, the function has local minima. X equal to 2, the function has local minima. X equal to, the function has local minima. Hope you understand. So there are 2 points of local minima and 1 point of local maxima. Thus m is the number of points of local minima. How many points of local minima? 2. M is equal to 2. And the number of points of local maxima is n. So n is 1. So m plus n they ask. M plus n is 3. Option A is the answer. M plus n is equal to 2 plus 1 is equal to 3. Hope you understand this simple question. Detailed solution is also shown here. Okay, all these things. Answer is option A. F dash of x changes sign from positive to negative. All those things explained in detail as we got. Move on to the next one. A is positive if the function f of x, a cubic polynomial is given, attains its local maximum and minimum values at the points x1 and x2 respectively, such that x1 into x2 is 54. Want to find a plus x1 plus x2 equal to how much? Question asked on 4th of April, 2nd shift, 2025. The function f of x attains local maxima and local minima. Okay. Whenever the function attains the local maxima and minima, at that point I can conclude that derivative should be equal to 0. Correct? So we'll differentiate and use that condition. F dash of x equal to 0 at x1 and x2. Because x1 and x2 are the points of local maximum and local minimum. Correct? At that point derivative should vanish. Using that condition I can find out. F dash of x equal to f dash of x. What is f dash of x? Derivative of 6x cube. 6 into 3x square, 18x square. Minus 45a into x square. Minus 90ax. Derivative of 108a square. X. That is 108a square. Correct? Derivative of 1 is 0. They told x1, x2 are the points of local maxima and local minima. So x1, x2 should be the roots of this equation, correct? Because at the point of local maxima and local minima, what happens? Derivative should vanish. Derivative becomes 0, correct? So x1 and x2 should be the roots of this equation, I can tell. x1 and x2 are the roots of this equation. Because at the point of local maxima and local minima, derivative should be equal to 0. So x1, x2 are the roots of this equation. If x1, x2 are the roots of the quadratic equation, we know the relationship between the roots and the coefficient. Sum of the roots is minus b by minus coefficient of x by coefficient of x square. Product of the roots is c by a, constant term divided by coefficient of x square. And x1, x2 is already given to us, 54, correct? So using the relationship between the roots and the coefficients, x1, x2 should be the roots of this, because x1, x2 are the points of local maxima and local minima, they told. So f dash of x1 should be 0, f dash of x2 equal to 0, correct? Since x1, x2 are the roots of the equation, we have f dash of x1 should be equal to 0 and f dash of x2 should be equal to 0. Because they are the points of local maxima and local minima. So from that, I can conclude that sum of the roots x1 plus x2 minus coefficient of x by coefficient of x square minus of minus 90a divided by 18. How much we get? That is equal to minus of minus plus 5a. Correct? Product of the roots x1 into x2, that is c by a, 108a square, 108a square divided by 18. That simplifies to 6a square. Is already given in the question that the product of x1 and x2 is 54, and they mentioned that a is positive. 6a square is equal to 54. So a square is equal to 9. A square is equal to 9. That means a is equal to 3. Correct? Because a is positive, they told. A is positive. Don't take a equal to minus 3 because a is positive is already mentioned in the question. So want to find a plus x1 plus x2. So x1 plus x2 becomes how much? Therefore, x1 plus x2 is already we have 5a, correct? So x1 plus x2 will be equal to 5a. A how much we got? 3. 5 into 3, that is 15. x1 plus x2 is 15. What we need to find? Therefore, a plus x1 plus x2. A plus x1 plus x2. What is the value of a? We got 3. x1 plus x2 is 15. 15 plus 3, 18 is answer. Option C. Very simple question asked on application of derivatives. Answer is 18. Option C. Move on to the next one. Question number 4. X equal to minus 1 and x equal to 2 be the critical points of this function. M and capital M, small m and capital M respectively be the absolute minimum and absolute maximum values of this function in the closed interval minus 2 to minus half. Want to find mod of m plus m. They told to use log 2 value as 0.7, 0.7. X equal to minus 1 and x equal to are the critical points of this function f of x. F dash of x you find out. F dash of x. What is f dash of x? Derivative of x cube, 3x square. Derivative of ax square, that is 2x into a. 2x a. Derivative of log of mod x is 1 by x. So b by x, right? And derivative of 1 is 0. Okay. So f dash of x I got. They told x equal to minus 1 and x equal to are the critical points. At the critical point, derivative should be equal to 0. At x equal to minus 1, I'll take derivative equal to 0. F dash of minus 1, we find out. F dash of minus 1 how much? 3 into minus 1 square, that is 3. 2a into minus 1, minus 2a, plus b by minus 1, minus b. That should be equal to 0. F dash of minus 1 equal to 0. F dash of 2 also should be equal to 0. F dash of 2 you find out. Put x equal to in this. 2 square 4. 4 into 3 is 12. 2 into 2, that is 4a. 4a plus b by 2 is equal to 0. Putting x equal to 2 and writing. Solve these two equations simultaneously. Find the values of a and b. Then substitute. You'll get the, then you can find the critical point of this function f dash of x already given minus 1 into the critical points. Correct? I'll get f dash of x as a cubic polynomial. So you get one more critical point. Correct? So two critical points are already given to us. F dash of x equal to 0. Correct? Get the values of a and b first. From the second equation, I can multiply the entire equation by 2. B by 2 is there. Now I want to get rid of this 2. So multiply the entire equation by 2 for this. What we get? 24 plus 8a plus b equal to 0. Multiplying this equation by 2. This we call equation 1. This we call equation 2. Add equations 1 and 2. Plus b minus b cancels. Adding 1 plus 2. Equation 1 plus equation 2 gives what? 24 plus 3, 27. 8a minus 2a, that is 6a. Minus b plus b cancels. So 6a equal to minus 27. From this we get 6a is equal to minus 27. What we get is a is equal to minus 9 by 2. Correct? A is equal to minus 9 by 2. Put a equal to minus 9 by 2 in one of the equations. From this, I'll get b is equal to 3 minus 2a. Correct? Minus b, take that. So b is equal to 3 minus 2a. So what you get is 3 minus 2 into value of a is minus 9 by 2. 2 cancels. Minus into minus plus. Correct? 9 plus 3 is 12. I got the values of a and b. Got the values of a and b that you can substitute there. F dash of x. So f dash of x becomes equal to how much from this? F dash of x is equal to 3x square. 2x into a. A is minus 9 by 2. 2 cancels. Correct? A is minus 9 by 2. 2 cancels. I'll get minus 9x. Minus 9x. And b by 12. Correct? B is 12. So 12 by x. 12 by x is equal to 0 I'll do. If you multiply throughout by x, I'll get 3x cube minus 9x square plus 12 equal to 0. The cubic polynomial, correct? Already minus 1 is a root of this because they told it's a critical point. No, definitely minus 1 satisfies. F dash of minus 1 is already 0, we know, because x equal to minus 1 is a critical point. If you substitute no x equal to minus 1, definitely it satisfies. Minus 1 cube is minus 1. Minus 1 into 3, minus 3. Minus 3 plus 12 is 9. Minus 9 into minus 1 square is minus 9. Minus 9 plus 9 becomes 0. So x equal to minus 1 is a root, right? So x plus 1 should be the factor. You can divide this polynomial of left hand side. Okay, left hand side of this equation. Divide by x plus 1 and get the other factor. Correct? So I'll divide this polynomial by x plus 1 because x equal to minus 1 is a root. X plus 1 should be the factor for this. So I'll find the other factor. Okay, divide this polynomial by x plus 1. 3x cube minus 9x square plus 0x plus 12 I'll write I'm dividing by x minus x plus 1. So x into 3x square will give 3x cube. 1 into 3x square, that is 3x square. Here minus, this is minus 12x square plus 0x plus 12. This had to multiply by x into minus 12x will give minus 12x square. So minus 12x square, 1 into minus 12x, that is minus 12x. Change the sign, so this will become plus, this will cancel. 12x plus 12 I am getting, and this I have to multiply by 12, correct? 12 into x becomes 12x, 1 into 12 is 12, change the sign, minus will cancel, becomes 0, remainder is 0. So the other factor will be this, 3x square minus 12x plus 12 equated to 0. You can divide by 3 and write. If you divide by 3 and write, this will be x square minus 4x plus 4 equal to 0, correct? Which is x minus 2 the whole square, correct? X equal to minus 1 was a root, correct? If you divide by 3, I'll get x square minus 4x plus 4 equal to 0, which is x minus 2 the whole square equal to 0. X minus 2 the whole square equal to 0. I think mistake has happened or what? X equal to 2 is a root. Okay, yeah, x equal to 2 is a root. Yes, that's correct. From this, I can write it as x minus 2 the whole square equal to 0. X equal to 2. I'll get x equal to 2. But 2 does not lie in this interval, right? 2 is a critical point, but 2 does not lie in the interval minus 2 to minus half. 2 does not belong to the interval minus 2 to minus half. X equal to is a repeated root actually. X equal to is a repeated root. Actually, x equal to is already critical point. Here I am getting x equal to as a repeated root. So critical points, the roots of this cubic polynomial are minus 1, 2 and 2. 2 is a repeated root. Okay. I am not getting anything different root than these two. Correct. So critical points were given to us actually. 2 is a repeated root. But 2 does not lie in this. We know to find the absolute maximum, absolute minimum, what we do is we find the function value, we find the critical points, evaluate the function at the critical points and also evaluate the function at the end points of the interval, correct? And compare the values. Greatest among them is absolute maximum, least among them is absolute minimum. So 2 is a critical point definitely, but it does not lie in this interval. So no need to consider that. So only I'll consider minus 1. Minus 1 lies in this interval, correct? Minus 1 lies. So you find out f of minus 1, find out f of minus 2 and f of minus half. 3 values I have to find out. I need to find f of minus 2. F of minus 2 you find out. F of minus 2 at the end points and at the critical point, comparing the function values. My f of x is here. Where is my f of x? After simplifying the value of f of x, I need to write it, okay? Because I not written f of x, I wrote f dash of x. F of x I shall write down. Okay, f of x I'll write here itself. I'll write f of x here. My f of x is equal to how much? By putting a is equal to minus 9 by 2 and b is equal to 12. A is equal to minus 9 by 2 and b is equal to 12, you write. What do you get? F of x. That is x cube. A how much? Minus 9 by 2. Minus 9 by 2 x square. B is how much? 12. 12 into log of mod x. 12 into log of mod x plus 1. That is my f of x. Correct? F of minus 2 you find out. F of minus 2. Put x equal to minus 2. Minus 2 cube is minus 8. Minus 9 by 2 into minus 2 square. Minus 2 square is 4. 2 ones are 2 2s are minus 18 I'll get. And 12 into log of mod minus 2. Mod minus 2 is 2. 12 log 2 plus 1. Minus 8 minus 20 minus 18 minus 26. Minus 26 plus 1 minus 25. Log 2 is, they told to use log 2 as 0.7. This is 0.7. Correct? 12 into 7 is 84. So I'll get plus 8.4. 8.4. This is simplified to how much? Minus 16.6, right? I'll get minus 16.6. Next, we find out f of minus half and also find out f of minus 1. Okay, critical point is there. F of minus 1 we find out. F of minus 1 is how much? Minus 1 cube is minus 1. Minus 1 square is 1. Minus 9 by 2. X is minus 1. Minus 1 square is 1, correct? 12 into log of mod minus 1. Mod minus 1 is 1. Log 1 is 0, correct? Plus 0 plus 1. So I'm getting 2 minus minus 1 plus 1 cancels, correct? We get minus 4.5. Next we find out f of minus half. F of minus half. Minus half cube is minus 1 by 8. Minus 1 by 8. Minus half square is 1 by 4. Minus 9 by 2 into 1 by 4. Minus 9 by 8. Correct? Minus half square is 1 by 4. Minus 9 by 2 into 1 by 4. 9 by 8. And log of mod minus half. Mod minus half is half. Log 1 by 2 is minus log 2. So we'll get minus 12 log 2. Minus 12 log 2 plus 1. This will be minus 10 by 8. Minus 10 by 8, correct? Minus 1 by 8, minus 9 by 8. Minus 10 by 8, minus 5 by 4. Minus 5 by 4 plus 1, minus 1 by 4. Minus 1 by 4, minus 0.25. Minus 0.25, this is 8.4, correct? Minus 8.4, log 2 value is 0.7. So minus 8.4 and minus 0.4. That will be minus, how much do you get? Minus 5 by 4 plus 1, minus 1 by 4, minus 0.25, minus 0.25 and minus 8.4, minus 8.65 I'll get. This is minus 8.65. Hope your answer is correct. And if you compare these values, no, the least value is going to be minus 16.6. That is absolute minimum value is small m according to the question. This is small m and this is capital M, correct? Minus 4.5 is the greatest among this. And if you find mod of m plus m, I'll write the answer here. Therefore, required is mod of m plus m, correct? That's equal to capital M is minus 4.5. Capital M is minus 4.5. Small m is how much? Minus 16.6. If I simplify this, I'm going to get 16.6 plus 4.5, 21.1, minus 21.1. Mod of minus 21.1 is 21.1. Option A is the answer. Okay, just compare, you can see the values, what I got, correct, no? Minus 4.5, minus 8.65, minus 16.6. So answer is 21.1. Least and the greatest value, you find out and add it and put the modulus for that. Move on to the next one. A function f from R to R is a polynomial function of degree 4 having extreme values at x equal to 4 and 5. Limit extends to 0, f of x by x square is given to be equal to 5. Find f of 2. Simple question. Limit concept is also required here. Given a polynomial function of degree 4. So we should take a polynomial function of degree 4 first. F of x. F of x is a polynomial function of degree 4. Okay, according to the question, let f of x be equal to, let f of x be equal to a into x power 4 plus b into x cube plus c into x square plus dx plus e. We take a polynomial function like this, where a, b, c, d, there are 5 constants. Okay, so polynomial function of degree 4 as told in the question. It has extreme values at x equal to 4 and 5. Means at the point of extremum, what you can tell, derivative vanishes. Extreme values means either it's a point of maxima or minima. So f dash of 4 should be equal to 0. F dash of 5 also should be equal to 0. And further limit extends to 0, f of x by x square is given as 5. So f of x by x square we find out, and limiting value for that is going to be equal to 5. Given limit x tends to 0, f of x by x square is equal to 5. F of x divided by x square is given to be equal to 5. So what do you get from this? Limit x tends to 0, limit x tends to 0, f of x by x square. You divide by x square and write. If you divide by x square and write, this will become ax square plus bx plus c plus d by x plus e divided by x square. Correct? Dividing by x square and writing is equal to 5. Like this I get. Now, limit of this function is existing finitely. 5 is a finite number. It's a well-defined number. And the limit of the function is going to exist finitely. So, for limit to exist, I insist the condition that d and e should be equal to 0. Correct? Because if d is non-zero, then limit is not going to exist, because already as x tends to 0, denominator is 0. Suppose numerator is non-zero. Non-zero by 0 means limit becomes infinite, correct? So limit is already a finite number. So we insist the condition that d and e both should be equal to 0 for limit to exist finitely. Even for this also, here also denominator is becoming 0. So I insist the condition that e should be equal to 0. So as limit is finite, limit is a finite value, we should have d equal to 0 and e equal to 0. D and e both should be equal to 0. D and e both should be 0. And when you apply limit, no, a into 0 square 0, b into 0 0. So limit of this will become c. After taking d and e 0, and when you apply limit for this will become 0. A into 0 square 0, b into 0 0. Limiting value of this is going to be c, that is equal to 5. Therefore c is equal to 5. C is equal to 5. So D, E, C we got. So our polynomial of degree 4 will get simplified, because D is already 0 and E is already 0 and C is 5. I got the 3 constants. Remaining 2 constants A and B can be got by using the condition that it has extreme values at 4 and 5. So extreme values means it's a point of maxima or minima. At the point of maxima or minima, what happens? Derivative should vanish. So I can tell f dash of 4 equal to 0 and f dash of 5 equal to 0. So I'll simplify my polynomial f of x now. Therefore, f of x becomes equal to what? A into x power 4 plus b into x cube plus, I got the value of c as 5, so I'll write 5x square. D is 0, E is 0. I won't write these two terms. They are dead, gone, 0. Now find f dash of x from this and use f dash of 4 0, f dash of 5 0, so that they get the 2 constants a and b. So I determine the polynomial f of x. Then you can find f of 2. A simple question. Okay. Now f dash of x from this. F dash of x is equal to how much? Differentiate this. Derivative of 4 ax power 4 is 4ax cube. Derivative of bx cube is 3bx square. 3bx square. Derivative of 5x square is 10x. Since f has extreme values, at 4 and 5, since f has extreme values at x equal to 4 and x equal to 5, f dash of 4 is equal to 0, x equal to 4 and x equal to 5. What should we have? F dash of 4 should be equal to 0. F dash of 4 means what? Put x equal to 4 in this. 4 cube is 64. 64 into 4, 256. 256a. Put x equal to 4. 4 square 16. 16 into 3 is 48 into b plus 10 into 4, 40. That should be equal to 0. One condition. Using f dash of 4. Correct? 4 cube is 64. 64 into 4 is 256. 4 square is 16, 16 3s are 48, 10 into 4, 40. Also I should have f dash of 5 equal to 0. F dash of 5 equal to 0 because the function has extreme values at x equal to 5. 5 cube is 125. 125 into 4, that is 500. A. Put x equal to 5. 5 square is 25. 25 into 3 is 75. 75b, correct? 10 into 5, 50 equal to 0, correct? Now we need to find the values of a and b from these two equations. Once we get the values of a and b, we can substitute in the given function f of x in this. Here I can substitute. Then I can find f of 2, correct? Here I can substitute the values of a and b, then I can find f of 2. First equation, I can divide throughout by 8. 8 is common factor there, correct? 8 into 32, correct? So divide this by 8. The first equation. This is second equation. First equation, divide by 8 and write. What I'll get? 32a, correct? 8 3s are 8 2s are 32a plus 8 6 are 48. 6b is equal to minus 5, dividing by 8. Second equation you can divide by 25. Dividing by 25. 25 3s are 75. 25 2s are 50. 25 into 20 is 500. Correct? So this becomes 20a plus 3b is equal to minus 2, dividing by 25. And this I can multiply by 2. So that this will be 40a plus 6b is equal to minus 4. This is called equation 3. This is called equation 4. We can subtract equations 4 and 3. So that I'll change the sign here. Minus, this will be plus. 6b is going to cancel. Minus 40a plus 32, minus 8a, correct, is equal to plus 4 minus 5, that is minus 1. So we'll get a equal to 1 by 8. A value is 1 by 8. Value of a is 1 by 8, you can substitute here. 32 into 1 by 8 is 4, correct? So 32 into 1 by 8, that is 4 plus 6b is equal to minus 5. So 6b is equal to how much? 6b is equal to minus 5 minus 4 minus 9. So I'll get the value of b as minus 3 by 2. My f of x will be got now. And then I can find f of 2. F of x is equal to how much? 1 by 8 into x power 4. 1 by 8 into x power 4. B value is minus 3 by 2. Minus 3 by 2 into x cube. Plus 5x square. F of x we got. Now find f of 2. F of 2 means put x equal to 2 and write from this. Therefore, f of 2 will be equal to how much? 2 power 4, 16. 16 into 1 by 8 is 2. 2 cube is 8. 8 into 3, 24. 24 by 2, that is 12. Correct? 2 square is 4. 4 into 5 is 20. 20 plus 2, 22. 22 minus 12, that is 10. Correct, no? 22 minus 12, answer is 10. Option B is the answer. Simple question, not a big deal at all. Answer is 10. Option B. Move on to the next one. Question number 6. The function f of x given as x by 3 plus 3 by x plus 3 for x not equal to 0 be strictly increasing in the interval minus infinity to alpha 1 union alpha 2 to infinity and strictly decreasing in the interval open interval alpha 3 to alpha 4 union alpha 4 to alpha 5. Summation j equal to 1 to 5 alpha j square is equal to how much to find out. This is a very simple question actually, CET level question actually. We know how to find the derivative and critical points and we can use Vavicom method and get the answer. Otherwise I can take it as a standard result also. We have a result actually, a function of the type x by a plus a by x plus some constant. The constant can be present or doesn't, if it's not present also doesn't matter. So x by a plus a by x, no, it is going to be strictly increasing in the interval minus infinity to 3 union 3 to infinity. Directly I can tell by using this result. See, I'll write the result here. F of x equal to x by a plus a by x plus some constant. Here the constant is 3 itself. But constant can be a or k, whatever, no problem. For x not equal to 0 is going to be strictly increasing in the interval minus infinity to a union a to infinity, minus infinity to minus a, union a to infinity. Okay, minus infinity to minus a and union a to infinity, and it is strictly decreasing in the interval, strictly decreasing in the interval minus a to 0 union 0 to a. 0 has to be left, no? So we can't include a 0 because x not equal to 0, because function doesn't become defined at x equal to 0. So this is the result actually, standard result, directly I can tell. So alpha 1 should be 3, alpha 2 should be, alpha 1 should be minus 3, alpha 2 should be 3 according to this. And here also, alpha 3 is minus 3, alpha 4 is 0, alpha 4 is 0, alpha 5 is 3, over. We'll get the answer. 3 square 9, 9 into 4, 36 is the answer. Directly we can tell. Okay. If I want the actual method, I'll do it. F dash of x. F dash of x is equal to what? Derivative of x by 3 is 1 by 3. Derivative of 3 by x, 3 into 1 by x. 3 into derivative of 1 by x is minus 1 by x square. So minus 3 by x square. Correct? Get the critical points. F dash of x equal to 0. 1 by 3 is equal to 3 by x square. So I'll get x square is equal to 9. X square is equal to 9 means x equal to plus or minus 3. Even 0 is a critical point, correct? Even x equal to 0, the function derivative is not defined at x equal to 0. Even x equal to 0 is a critical point. X equal to 0 is a critical point. So critical points are plus or minus 3 and 0, correct? X equal to 0 plus 3 minus 3 are the critical points. You can mark them on the number line. Minus 3 is here, 0 is here, 3 is here. If you take a value greater than 3, say f dash of 4, f dash of 4 will be how much? 1 by 3 minus 3 by 16. 4 square is 16, 3 by 16. If you calculate 1 by 3 minus 3 by 16, it is going to be positive, correct? So we will get positive value. If you take f dash of 1, 1 by 3 minus 3 by 1 square, that is going to be negative. If you find f dash of minus 1, that is also negative only. If you find f dash of say minus 4, f dash of minus 4 is same as f dash of 4, it is going to be positive. So here the function is increasing. Derivative is positive, the function is increasing. Here it is decreasing. Here it is decreasing. Here it is increasing. So where it is increasing? In the interval minus infinity to minus 3 union 3 to infinity. Derivative is positive, the function is strictly increasing. The derivative is negative, the function is strictly decreasing, we know, correct? So according to that, f is strictly increasing in the interval. F is strictly increasing in the interval minus infinity to minus 3 union 3 to infinity, and f is strictly decreasing in the interval. F is strictly decreasing in the interval minus 3 to 0 union 0 to 3. So according to the question given, minus infinity to alpha 1 union alpha 2 to infinity. This is alpha 1. This is your alpha 2. This is alpha 3. This is alpha 4. This is alpha 4. Alpha 5. Correct? So they asked to find summation j is equal to 1 to 5 alpha j square. Required is summation j is equal to 1 to 5 alpha j square. That means alpha 1 square plus alpha 2 square plus alpha 3 square plus alpha 4 square plus alpha 5 square. Alpha 1 is minus 3, minus 3 square 9. Alpha 2, 3, 3 square 9. Alpha 3 is minus 3, minus 3 square 9. Alpha 4 is 0, 0 square. Alpha 5 is 3, 3 square 9. Answer is 36. Option C. Quite simple question. CET level question I can tell, okay? Not a JEE level question at all. Answer is shown in detail. Positive, negative, negative, positive. Where it is increasing, decreasing, everything is given in detail. Move on to the next one. Question number 7. A spherical chocolate ball has a layer of ice cream of uniform thickness around it. When the thickness of the ice cream layer is 1 centimeter, the ice cream melts at the rate of 81 centimeter cube per minute. and the thickness of ice cream layer decreases at the rate of 1 by 4 pi centimeter per minute. The surface area in centimeter cube of the chocolate ball without the ice cream layer you have to find out. Question asked on 23rd of January, second shift, 2025. Similar type of question was asked earlier also in the JEE main exam. So not a difficult one, not a new question at all. A spherical chocolate ball as a layer of ice cream. So I'll represent a circle only to draw the sphere. We can't represent a sphere on the board. Sphere is a three-dimensional figure. So I'll draw the circle itself, okay, to represent the sphere. Spherical chocolate ball, okay, has a layer of ice cream of uniform thickness, has a layer of ice cream like this, layer of ice cream of uniform thickness, okay, rough sketch, uniform thickness around it. Thickness of the ice cream is 1 centimeter. At that instant, ice cream melts at the rate of 81 centimeter cube. This is ice cream layer. This is ice cream. This is chocolate ball. This is a chocolate ball is coated with an ice cream layer. Chocolate ball is coated with what? An ice cream layer of uniform thickness. This is an ice cream layer. This is ice cream layer. Let the thickness of the ice cream be x called. Thickness of the ice cream be x. And the radius of the chocolate ball be r. Radius of the chocolate ball be r. Thickness of the ice cream layer be x. Okay. So now when the thickness of the ice cream layer is 1 centimeter, when x is 1 centimeter, at that instant ice cream is melting at the rate of 81 centimeter cube per minute. Ice cream is melting at the rate of, let V be the volume of the ice cream. So dV by dt is given. dV by dt. Ice cream is melting at the, melting means it decreases. So I'll put a negative sign for that. Minus 81 centimeter cube per minute. Ice cream is melting at the rate of 81 centimeter cube per minute. And the thickness of ice cream layer decreases at the rate of, x be the thickness of the ice cream. So thickness of the ice cream decreases. So dx by dt. dx by dt is equal to what? That is negative because it is decreasing. Minus 1 by 4 pi centimeter per minute. What we need to find is the surface area of the chocolate ball without the ice cream layer. And this happens when x is 1 centimeter. When the thickness of the ice cream layer is 1 centimeter, I need to find out. Thickness of the ice cream layer is 1 centimeter. At that instant, I have to find out the surface area of the chocolate ball without the ice cream. Okay. So now I write the formula for volume of the ice cream layer. What is volume of the ice cream? Volume of the ice cream is going to be V is equal to 4 by 3 pi spherical in shape r plus x the whole cube minus 4 by 3 pi into r cube. Correct? Volume of the chocolate ball plus ice cream minus volume of the chocolate ball. That gives volume of the ice cream. Chocolate ball plus ice cream layer together I took. Correct? If you want to find the volume of the chocolate ball plus ice cream, therefore that resultant radius will be r plus x. So r plus x I taken 4 by 3 pi. Instead of r cube, I wrote r plus x the whole cube. This will represent the total volume of the chocolate ball with ice cream. Okay, minus volume of the chocolate ball. Volume of the chocolate ball is constant, correct? It is not melting. Only ice cream is melting here. So when you differentiate this, no, this will become 0. Differentiate this with respect to time. Differentiate with respect to time. What we get? dV by dt is equal to constant into variable. Constant keep as it is. 4 by 3 pi is constant. Derivative of r plus x the whole cube is 3 times r plus x the whole square into derivative of r plus x. R is constant. Derivative of constant is 0. Derivative of x with respect to t is dx by dt. And derivative of 4 by 3 pi r cube is also constant. Derivative of constant is 0. Here 1 3 is going to cancel. dv by dt is given to us minus 81. You can substitute the value is equal to 4 pi into r. How much? R we have to find out. We don't know. R plus x is 1. At that instant all these things are happening. Dx by dt is minus 1 by 4 pi. Dx by dt is minus 1 by 4 pi. Correct? 4 pi is going to cancel. Minus minus will cancel. So what is left is 81 is equal to r plus 1 the whole square. R plus 1 the whole square is 81 means r plus 1 becomes 9. Don't write minus 9. Radius can't be negative. So I'm getting r is equal to 8. R is equal to 8. What we need to find is surface area of the chocolate ball. So surface area of the chocolate ball is 4 pi r square. Correct? Because r is the radius of the chocolate ball. So surface area of the chocolate ball without the ice cream is 4 pi r square. 4 pi into radius we got it as 8. So 8 square. 8 square is 64. 64 into 4. 256 pi. So much centimeter square. That is surface area of the chocolate ball in centimeter square. In centimeter square it should be, not cube. Centimeter square. Okay. Surface area is measured in centimeter square. So 256 pi centimeter square is the answer. Option D. Detailed explanation is also shown here. A nice figure is also drawn representing a sphere. Circle itself is drawn instead of drawing a sphere. So this is the layer of chocolate ball coated with an ice cream. X is the thickness of ice cream. And here they taken R as the radius actually. Actually in my figure I took R as this much. This is R actually. In my figure. Okay, don't take this. Don't take this. This is your R. R plus X I took. This is R plus X as I did. But this figure is different. But steps are correct. Okay. You can make a small change here. This is R and this is X. So total is R plus X for the volume of chocolate ball with ice cream. Okay, make a small correction in this figure. What I've done is correct here. I took the chocolate ball radius as R and the thickness of ice cream as X. Hope it's clear. Move on to the next one. Sum of all local minimum values of this function you have to find out. Can you try this? Question asked on 28th of January 1st, 2025. Sum of all local minimum values of this function. So their modulus function is there. No, split this. Okay. You know, mod x is x if x is greater than or equal to 0. Mod x is minus x if x less than 0. I'll split this into two cases. Okay. Minus 1 to 2 will be minus 1 to 0 and 0 to 2. Correct. So I'll split the second line in two cases. My function f of x will be 1 minus 2x. This is for x less than minus 1. Next, second line, we divide in two cases there. 1 by 3 into 7 minus 2x. Mod x will be minus x for x between minus 1 and 0. Minus 1 less than or equal to x less than 0. And mod x will be x for x greater than or equal to 0. Correct? So 1 by 3 into 7 plus 2x. This is for 0 less than or equal to x less than or equal to 2. Correct? So x greater than or equal to 0, mod x becomes x. And the last line you can keep as it is for time being. 11 by 18 into x minus 4 into x minus 5. That is for x greater than 2. Now we need to find the sum of all local minimum values. That means use the condition that f dash of x equal to 0, f double dash to be equal to negative, or you can go positive. F double dash should be positive for local minimum. I'll use first derivative test. Instead of using the second derivative test, I shall apply the first derivative test and see whether derivative sign changes from positive to negative or negative to positive. If it changes from negative to positive, I'll have local minima. Such points I want. Okay. We'll differentiate this. F dash of x. F dash of x is equal to Derivative of 1 minus 2x is minus 2. This is for x less than minus 1. Derivative of 1 by 3 into 7 minus 2x. 1 by 3 is constant, keep as it is. Derivative of 7 minus 2x is minus 2. So minus 2 by 3 will get there. Here will get minus 2 by 3. This is for x between minus 1 and 0. Derivative of 7 plus 2x is 2. So I'll get 2 by 3 there. 2 by 3. This is for x between 0 and 2. 0 less than or equal to x less than or equal to. And for x greater than 2, I can differentiate this polynomial function. If you multiply, I'll get what? X square minus 4x minus 5x. X square minus 9x plus 20. Correct? X square minus 9x. So differentiate that and write. That will be 11 by 18 into derivative of x square is 2x and derivative of 9x is 9. This is for x greater than 2. Here there is a critical point actually, 9 by 2. 9 by 2 is a critical point. And at minus 1, see, derivative sign does not change. X less than minus 1, derivative is negative. X greater than minus 1, derivative is negative only. In the neighborhood of x equal to minus 1, derivative sign does not change. So it's not a point of local minima. When x equal to 0, you see, x less than 0, derivative is negative. X greater than 0, derivative is positive. I can write f dash of 0 minus. 0 minus means slightly less than 0. For x less than 0, derivative is negative. And f dash of 0 plus. F dash of 0 plus. 0 plus means x greater than 0, derivative is positive. Correct? So the derivative sign changes from negative to positive at the neighborhood of x equal to 0. So x equal to 0 is the point of local minima. Correct? Negative to positive. Therefore, derivative sign changes there. X equal to 0, f has local minima. The function f has local minima at x equal to 0. Now, at x equal to 2, I should divide actually, correct? For x less than 2, it is 2 by 3. But here I get a critical point as 9 by 2. So I'll divide this f dash of 9 by 2 minus and f dash of 9 by 2 plus. What happens? If you take x greater than 2, if you take less than 2, derivative is positive. If you take greater than 2, say you take x equal to 3. If you take x equal to 3 here, 2 into 3, 6. 6 minus 9, negative again, correct? So, if we take 2.1 also it's negative. Positive to negative means it becomes local maxima. X equal to 2 is the point of local maxima. That's not required here, correct? For less than 2, see, if you take f dash of 2 minus, correct? Slightly less than 2, derivative is positive, 2 by 3, positive. And if you take f dash of 2 plus, slightly greater than 2, if you take 2.1, 2 into 2.1, 4.2, correct? 4.2 minus 9 is going to be negative. So here derivative sign changes from positive to negative, that is local maxima. At x equal to 2, the function is local maxima. That is not required for us. Function is local maxima at x equal to 2. Next, what we have, the critical point I can get from here is at 9 by 2. 2x minus 9 becomes 0 at x equal to 9 by 2. If you take a value of x slightly less than 9 by 2, derivative is going to be negative. Correct? F dash of 9 by 2 minus. 9 by 2 minus means slightly less than 9 by 2. If you take, derivative is negative. And f dash of 9 by 2 plus. F dash of 9 by 2 plus. That is greater than 9 by 2. If you take, derivative is positive. Correct? At x equal to 9 by 2, the function is local minima. Derivative sign changes from negative to positive. So function is local minima. Hope you understand. So 9 by 2 and 0. So the sum of all local minimum values you have to find out. So local minimum value occurs at 0 and 9 by 2. So f of 0 I find out. 0 belongs to which interval? 0 belongs to the interval minus 1 to 0. Correct? Here it is. At a local minimum value I have to find out. Find the minimum value. Here it is. 0 belongs to this interval. Minus 1 to 2. So f of 0 I can find out. Therefore f of 0 will be f of 0, correct? 0 belongs to the interval minus 1 to 2. So here you put x equal to 0 and write. What do you get? 1 by 3 into 7 plus 2 into 0, correct? That is 7 by 3, f of 0. Next, at 9 by 2. 9 by 2 is a number which is greater than 2, correct? So I'll put x equal to 9 by 2 here. F of 9 by 2 I can find out. F of 9 by 2, that is point of minima, 9 by 2. So f of 9 by 2, you want to substitute there. 11 by 18, 11 by 18 into 9 by 2 minus 4. 9 by 2 is 4.5. 4.5 minus 4, that is half. 9 by 2 minus 5, that is minus half. So what we get is minus 11 divided by 18 into 4 is 72. Therefore, find out sum of this. We want to find sum of all local minimum values. One local minimum value is here, 7 by 3. Another one is minus 11 by 72. Therefore, required sum is how much? 7 by 3 plus minus 11 by 72. Minus 11 divided by 72. Take common denominator, 72. 3 into 24 gives 72. 24 into 7, that is 168. 72 into 1, so minus 11. So answer is 157 divided by 72. Required answer is option C. Nice question asked. To split the modulus function and also to split this quadratic polynomial, if you differentiate a linear, there you have to split, okay, to get the critical point. So required answer is 157 by 72. Hope I understood this. Please make a note of this. Practice all these questions. Okay, PYQs is most important. Detailed solution is also shown here. Okay. Move on to the next one. Function f of x given as integral from 0 to x square t square minus 8t plus 15 divided by e power t dt. X belongs to R. Number of local maximum and local minimum points of f you have to find out. Question asked on 22nd of January, second shift, 2025. So integration sign is there. So to find the derivative, we should apply Newton-Leibniz formula. Okay, f dash of x. So finding f dash of x means you can apply Newton-Leibniz formula. You're differentiating a definite integral, d by dx of integral from 0 to x square. What we have? T square minus 8t plus 15 divided by e power t dt. So we need to differentiate this definite integral. Integration and d by dx are going to cancel out. I am applying Newton-Leibniz formula. Hope you know what is Newton-Leibniz formula. Newton-Leibniz formula is like this. D by dx, I'll write here. D by dx of integral from u of x to v of x, f of t dt. F of t dt becomes equal to what? F of v of x into v dash of x minus f of u of x into u dash of x. This is the Newton-Leibniz formula. Integration and d by dx are going to cancel out. Substitute the upper limit, differentiate the upper limit, minus substitute the lower limit, differentiate the lower limit. This is called Newton-Leibniz formula. Understood? Integration and d by dx are going to cancel. Substitute the upper limit, differentiate the upper limit, minus substitute the lower limit, differentiate the lower limit. Newton-Leibniz formula we have. I am going to apply this Newton-Leibniz formula here to differentiate this definite integral, f dash of x. Here integration and d by dx are going to cancel. The variable for integration is t. In place of t, put the upper limit. Upper limit is x square. Wherever there is t, you put x square. To get the critical points, I am finding f dash of x because I want to find number of points of local maxima and local minima. Put t equal to x square. What I am going to get? X square square, x power 4 minus 8x square plus 15 divided by e power x square into derivative of x square, that is 2x. Substitute the upper limit into differentiate the upper limit, minus substitute the lower limit into derivative of lower limit. Derivative of 0 is 0. Correct? So gone. E power x square, you can take it up to numerator. E power minus x square I'll get. Okay, this I can factorize it. I can factor, first I'll write this 2 here. 2 I wrote there. 2 e power minus x square into x. If you factorize this, I'll get x square minus 3 into x square minus 5. Minus 3 minus 5. If you add, I get minus 8. If you multiply minus 3 and minus 5, you get plus 15. F dash of x equal to 0. F dash of x equal to 0. 2 can't be 0. Exponential function never becomes 0. Exponential function is always positive. Correct answer what you get for exponential function is always positive. So x equal to 0 is a critical point here. X can be 0. X square minus 3 0 means I'll get x square equal to 3. So I'll get x equal to plus root 3 minus root 3. If you take x square minus 5 0, I'll get x equal to plus or minus root 5. So x equal to root 5 minus root 5. So there are 5 critical points here. Correct? You can take the number line here. Take the number line. Represent these critical points. Mark the critical points on the number line. Okay, root 5 is a 2 point something. Correct? The greatest is 2 point. That root 5 is bigger among all these things. Next smaller is root 3 here. Next smaller is 0. Correct? Then minus root 3 and minus root 5. Minus root 3 is greater. Correct? Minus root 3 is greater than minus root 5 because it is closer to 0. If a number is negative, closer to 0 is bigger. Correct? So minus root 3, then minus root 5. These are the critical points. So we can write f dash of x in the simplified form like this. F dash of x is 2x into e power minus x square. Here x square minus 3, I can write it as x minus root 3 into x plus root 3. Correct? X square minus 5, I can write x minus root 5 into x plus root 5. Like this I can write. And you can use Wavy-Comm method to determine the sign scheme where the derivative is positive and where the derivative is negative. I can use Wavy-Comm method. What does Wavy-Comm method tells you that the coefficient of highest power of x should be positive, correct? So here the highest power of x is x square into x square, x power 4, x power 5, it's positive only. Coefficient of x power 5 is 2. 2 e power minus x square. E power minus x square is always positive. So coefficient of x power 5 is 2, it's positive. So right side will start. Right side of root 5 is going to be positive. So root 5 is got from where you see. Root 5 is derived from x minus root 5, correct? Root 5 from where you got the critical point. Root 5 is the critical point derived from x minus root 5 equal to 0. By equating x minus root 5 equal to 0, I got root 5. So its power is 1, no? Odd number. So odd number means again the sign changes. Start from extreme right side, okay? See that coefficient of highest power of x is positive. If it is positive, right side, extreme right side will be positive. If the coefficient of highest power of x is negative, you start from right side, extreme right side is negative. Here coefficient of highest power of x, that is x power 5, coefficient is 2, positive. So extreme right is positive. Here it is negative here, okay? Negative. Because root 5 is got from this. And next number is root 3. Root 3 got from where? Root 3 is got from x minus root 3, correct? Its power is 1. 1 means again odd number. Odd number means sign changes. 0. 0 is got from where? X. What is the power? Power of x 1. Again odd number. Again sign changes. Minus root 3 got from where? Minus root 3 is derived from x plus root 3, correct? I am equating x plus root 3 to 0, hence getting minus root 3. So x plus root 3 power 1. 1 is odd number. Again sign changes, becomes plus. Again minus root 5. Minus root 5 is got from x plus root 5, correct? What is its power? 1. Odd number. Again sign changes. So f dash of x, the sign scheme is like this at various critical points. So here what happens? At minus root 5 what happens? Derivative sign changes from negative to positive. So local minima. At minus root 3, derivative sign changes from positive to negative. So local maxima. You know, first derivative test. F dash of x changes the sign from negative to positive means at that point the function is local minima. If f dash of x changes the sign from positive to negative, at that point the function is local maxima. So minus root 3 is the point of local maxima. 0 what happens? At x equal to 0, derivative sign changes from negative to positive. So local minima. Root 3 at x equal to root 3, derivative sign changes from positive to negative. So local maxima. At root 5, derivative sign changes from negative to positive, local minima. So the points of local minima are points of local minima are points of local minima are x belonging to the set negative to positive local minima minus root 5. Negative to positive, that is 0, local minima. Negative to positive, that is root 5, local minima. So there are 3 points of local minima. So local minimum is 3 points. Points of local maxima, positive negative is at minus root 3 and also at root 3. Points of local maxima are points of local maxima are x belonging to the set which contains minus root 3 and plus root 3. So there are 2 points of local maximum and 3 points of local minimum, 2 and 3 respectively. Local maximum points is 2, local minimum points is 3, 2 and 3. Option A is the answer. Correct? At minus root 3, derivative sign changes from positive to negative. So local maxima. At root 3 also, derivative sign changes from positive to negative. Local maxima. At minus root 3 and plus root 3, the function is local maxima. At minus root 5, 0 and root 5, derivative sign changes from negative to positive, negative to positive, negative to positive, local minima. So 3 points of local minima and 2 points of local maxima. Option A is the answer. Okay, 2 points of maxima and 3 points of minima as shown here. In detailed explanation is given. Using wavy curve method, I got sign scheme is shown for the derivative f dash of x. Right side of root 5, extreme right you start positive, alternate plus minus because everywhere the power is odd number. Correct? X plus root 5 power odd number. X minus root 5 power 1 odd number. If the power is even number, sign does not change. Wavy curve method you should know properly. If you have not learned it, please learn wavy curve method. I will be teaching the wavy curve method also in detail later in the inequalities chapter. Okay, move on to the next one. I think this is the last question, 10th one. Set of all values of a for which the equation a cubic polynomial is given has 3 distinct real roots is the interval alpha beta, open interval. Find the value of beta minus 2 alpha. Question asked on 23rd of January 1st shift 2025. Take the given function as f of x. Let f of x be equal to, let f of x be equal to 5x cube minus 15x minus a. Take this as f dash f of x. Find f dash of x. They told that this polynomial has 3 distinct real roots. We will find f dash of x. Okay, f dash of x equal to how much? Derivative of 5x cube is 50x square. Derivative of 15x is 15 equal to 0 into. So I'll get divide by 15. I get x square minus 1 equal to 0. X square equal to 1 I'll get. Critical points are x equal to plus 1 and minus 1. X equal to 1 and minus 1. Also I'll find out f double dash of x. F double dash of x, that is 30x. Correct? Derivative of 15x square is 30x. Derivative of 15 is 0. F double dash of 1 I'll find out. F double dash of 1. 30 into 1, 30. F double dash of minus 1 is equal to how much? Minus 30. Second derivative is positive means the function has local minimum. Second derivative negative means local maxima. You can conclude that the function f has local maxima at x equal to minus 1 and local minima at x equal to 1. Function has local maxima at x is equal to how much? At x equal to minus 1. Second derivative is negative means local maxima. At x equal to minus 1, the function has local maxima. F has local minima at x equal to 1. Function has local minima at x is equal to 1. Correct? Second derivative is positive means local minima. Second derivative is negative means local maxima. So at minus 1 the function has local maxima and at x equal to 1 the function has local minima. And they told that the function has 3 distinct real roots. Okay. So I can plot the graph of this function roughly. Okay. Roughly we shall plot the graph of this function. It's a cubic polynomial. At x equal to 1 the function has local minima. At x equal to minus 1, the function is local maxima. So local maxima is like this. At x equal to minus 1, the function has local maxima. At x equal to 1, the function has local minima. And it has three distinct roots, they told, according to the question. This is a point of local maxima. This is the point of local minima. Correct? At x equal to 1, the function has local minima. At x equal to minus 1, the function has local maxima. So at x equal to minus 1, function has local maxima. F of minus 1 is positive, I can tell. And f of 1 is negative. Correct? By the graph. This height is above the x-axis. This height is below the x-axis. Clearly, I can tell f of minus 1 is positive and f of 1 is negative. So since the function has three distinct real roots, correct? 1, 2, 3. I can tell f of minus 1 into f of 1, this product should be negative. This product should be negative. F of x is already given to us. F of x. Correct? So f of minus 1 we find out. Minus 1 cube is minus 1. Minus 5 plus 15 it becomes. Minus 15 into minus 1 plus 15. 15 minus 5, 10. 10 minus a will get. 10 minus a. F of 1 we find out. F of 1 will be 5 minus 15 minus 10. Minus 10 minus a. This minus, no, take common minus and absorb this minus, this multiply this minus, take minus and common from this bracket and that minus multiply to this bracket. So what I'll get is a minus 10 into a plus 10 will be less than 0. This product is less than 0 means this a should belong to the interval minus 10 to plus 10. Minus 10 to plus 10, okay. So alpha beta. So according to the question, this is your alpha beta. Alpha is minus 10 and beta is 10. Alpha is minus 10 and beta is 10. So beta minus 2 alpha, how much? Find out. Beta minus 2 alpha. Beta is 10 minus 2 into alpha is minus 10. So we get 10 plus 20. Answer is 30. Because the function has local maxima at minus 1 and local minima at x equal to 1. This height is positive, this height is negative, correct? Because the function is having three distinct roots, means it is intersecting the x-axis at 3 points, correct? Local maxima, it has to come down here. This is local minima, it goes up like this, intersects the x-axis at 3 distinct points, 3 distinct real roots. So given function takes this form, correct? So answer is 30. Graph is also shown here. Okay, maxima, minima at minus 1 and plus 1. So this completes all the PYQs of April and January shift 2025. Totally there were 10 questions from this application of derivatives chapter. I'll be uploading more videos of JEE section, okay, and even CET and even NCERT syllabus also I'll start one by one. I'll start with differentiation, integration, most important big chapters I'll do. Exercise, each video will have one exercise. Along with concepts, I'll be explaining all the problems of the NCERT textbook, okay, which is quite important for board exams. Even the previous year questions also of different topics will do. I'll do different topics, maybe integration, I've done definite integration, indefinite integrals also, vector algebra, 3D geometry, even first few topics, complex numbers, quadratic equations, trigonometry I've done of April shift, I think. I'll do inverse trigonometry also of both April and January shift 2025, and also synopsis part of each and every chapter I'll be doing one by one, okay. We'll be uploading more and more number of videos in the coming days. Please subscribe to my channel, share it to your friends, forward it, okay. Please inform to your friends to subscribe to my channel. It's quite useful during the time of exam, and every day you can follow, okay. We have plan of uploading more than 800 videos in the next 1 year, okay. With this I'll conclude. Thank you.